I know. Yeah. The nerve of me. All right. Okay. So, for those of you that are wondering, what's the website? CSCI162.com. It redirects. There you go. You'll know you're on the right one because it's red and not blue. The other one was blue, right? Whatever the other color was, this one's red now. I'm just going to lower the lights a little bit better. Hopefully that's fine. The projector seems, the color seems, whatever. Anyways, 162, and it's winter 2025. Yeah, so the point of this course is, well, it builds on 161, but we definitely start to take a bit of a more focused approach on what we're going to learn. And it seemed like, anecdotally, it seems like most people that are self-taught programming skip data structures, which is weird because that tends to be like the first big core concept people learn if you're like going to university for learning how to program. 161, we start with like, okay, we're learning the code and whatnot. We learn all the basic things like, if, loop, all those operations. And we learn and play around with some data structures, don't get me wrong. And like we use a list in Python, which is great. That's a very general purpose data structure. It's fantastic. But we also talk about things like dictionaries and sets, They're a little different. They have their use cases. Yeah, what else? And here, the focus is going to be on data structures, and we're going to cover a couple of very specific ones. And the majority of this course is going to be focused on what we call linear data structures. I'll explain this shortly. But we will talk about a nonlinear data structure, like a tree, in a moment, or as we go. And along with the data structures, like, okay, data structures and algorithms. Oh, okay, they go hand in hand. Yes, but all the data structures are built with algorithms. So everything is still going to be algorithm-y. We're writing code to do everything. But at the end of the day, the focus is really on the data structures and the algorithms that we use and how the choice of data structures affects how our algorithms would work to solve a problem. And if we used a different data structure, maybe the algorithm would change to solve a given problem. There's a lot of exploration of this. Remember, computer science is not about programming. It's about like problem solving and thinking like pros and cons, design. There's a lot more to it than just like writing the code. We all know this by now, hopefully. You all know who I am. Raise your hand if you took 161 with me. Raise your hand if you didn't take 161 with me. Okay, perfect. You know who I am then. Great. All of this course content that is used to generate this website and everything is on this public GitHub repo. The only thing not on there are like the assignments, like the complete assignments. If you find, like last semester, if you find any issues, you want to contribute to the course content, you can submit a pull request. You did one last year to like fix typos or maybe rewrite something if like the grammar's weird or it could be explained better. That's strongly encouraged. If you want to do it, go look at the GitHub repo. A lot of people are intimidated by the idea of, oh, GitHub, that's a big programmer thing. It's too hard to like submit and make any changes. It's hilariously easy. It seems tough, but if you watch a 4-minute YouTube video, you'll be an expert. It's really, the bar's pretty low. It looks tough, but it's not. Class times, well, you found today's. It's the same time slot as last semester for 161, right? Right? We have labs, Thursday, Friday, same as last time. Office hours, come to office hours, woefully underused. It's wild. Like, I go back I think back 10 years ago when I was doing office hours, I'd have a lineup of 20 people every time. Like I'd have to set a time limit for each student. Now, these days, I don't think I get 10 people total through the whole semester. It's weird. It makes no sense. And invariably at the end of the semester, the course evals come back saying he's never available. All right, fine. Use office hours. I want you to come to office hours. It's much better. Course notes, it's presented the same way as 161. Labs, there's the labs. Obviously, I don't think we have time for 14 labs, so we just go with the flow. The assignments are there. Moodle is there for grades, and that says something. Don't worry, you'll learn about it. Moodle is going to be there. I'll come back to this, but Moodle is just going to be there like 161, just for submitting assignments and grades. I say this every time. The course grade on Moodle is entirely meaningless. I don't weight it. The number of emails I got, but my course grade was like 99. Well, yeah, you cheated on every assignment. You got 3% on the final exam. How did I fail? My course grade, you know why you failed. Come on. So just don't look at the final grade on Moodle. That's entirely meaningless. You can look like what you got on your assignments and tests, fine, but course grade does not mean anything. It's not your course grade. It's a lie. Moodle's lying to you. It's not my fault. It's Moodle's fault. And the course outline. Let's quickly look at the course outline. Okay, any questions so far? Okay, so yeah, whatever. 161 is the prerequisite. Does anyone not have the prerequisite? Cool. All right, you know who I am, Class Time Labs, Office Hours website, yeah. Mostly this website is going to be where all the content is, including the assignment descriptions. Moodle is where you submit your assignments. And YouTube, because the class recordings are on YouTube. Everyone totally watches those, right? Lecture textbook. Lecture notes are on this website. They are provided to you as a courtesy. I don't have to give you anything, by the way, right? I'm so nice to you, right? Like, look what I do for you, right? So just be aware that this is given to you to make your lives easier, not to make your lives harder. Don't have this and then ultimately make your life harder because, oh, this is there, so I can go look at it, so I won't come to class. Terrible idea. Terrible idea. That makes things way worse for you. Moodle, okay, website, assignment submitted through Moodle. Textbook for the class. This is the textbook. You don't need to buy it. Topics. Here are the topics that we're going to cover if you want to read through it. And here's the course breakdown with tentative dates. You'll see none of them are really set. They're all ish. There will be 4 assignments. They are all available to you right now. If you're really bored and you want to have at it, have at it. 4 assignments, 5% each, just like last semester. You notice there is only one midterm. We're 30%. I used to only ever have one midterm. About 2 years ago, I switched to 2 midterms, and I liked it, but I don't know anymore. And then the final exam, 40%. So 70% of your final grade is tests. I'm a little worried about that. I'm worried it's too low, but we'll see. And then there's this new lecture and lab activities. What's this? More on that in a moment. Assignments, same as last semester. It's on the course website. Read the description, go through your stuff, work through your stuff, submit on Moodle, right? Due dates. Do I accept lates? No. Of course, false. I never accept lates. It's due at 11:55 and it's 11:56 and you hit submit. I'll totally mark it, right? No. Why? Because 55 comes before 56, and 55 is the limit, and 56 is past that limit. That's why. Okay? No lates. Why no lates? Because if you submit it at 12:05, should I accept it? What about the person that submits it at 12:25, 1:05? Where do I draw that line? How about I draw the line where I said the damn line was? That's where we'll draw the line. And what about that student who goes, I don't have time to finish it completely because I procrastinated too much. I don't have time to finish it, but I'll get done what I can get done and submit it on time. And then somebody else submits it 20 minutes late. That I should totally mark right, but they took that extra time to finish it. One of those 2 people followed the instructions and one didn't. Am I really going to punish the person who followed the instructions by them submitting it on time but incomplete? Of course not. That's ridiculous. Why? In what world is that a rational thing to do? So yeah, no way. It's late. It's not marked. It's on time. You're great. And remember, this is a wild concept to a lot of people. 11:55 is like the time it's due. You don't have to submit it then. You can submit it any time between now and then. So don't, but my internet wasn't working. That sucks for you. That's it. Just don't submit it at 11:55. Easy peasy. And the best part about that, you get to bed at a reasonable time. You're not staying up till 11:55. You're going to feel better the next day. It's going to be great for everybody, okay? So just no lates, no nothing. Marking. There will be a TA. But mistakes happen. if there's an issue, like you can contact me, but 9 times out of 10, I'm not going to have the answer why like you lost a mark on an assignment. The TA will. So like you can contact the TA. They'll probably be able to answer it. If there is an issue though, where like something's just not making sense to you, you can ask me and we can try to get to the bottom of it. But the TA is going to be the person you're probably going to want to talk to about it. And if there's like a significant issue with the grade, like that, and you want like a remark or something, there's a 2-week limit. I can't go past. So if it's been like, since when you get it back though. Not when you look at it, when it's like returned to you. Tests, yeah, there's going to be a test. You can't cheat on the test. Missed test. There are no makeup tests. Unlike last semester, if you don't write a test and you obtain an approved accommodation, the weight gets shifted to the final. If you miss a test and you don't have an accommodation, you get 0. Okay? So you can get an accommodation, but you ain't writing that test. It's just the weight gets shifted to the final. Do you understand? Cool. Did I hit record? Good. Labs, they begin this week. Please listen to me. They begin this week. Okay? Okay. They're going to follow the same general style as last semester. I don't think I have any like pre-labs for this one. They'll just be like the main part of the lab followed by like CADIS problems. The CADIS problems are like supplementary, where the main part of the lab will be like specific topics I want you to do. It's always weird when I come to lab and people just jump to the CADIS problems and just do the CADIS problems, and it's like, okay, fine, but the main part of the lab contains the content I actually want you to look at. Like that's what the point of the lab is, that stuff. Lecture and lab activities. Okay. I'm going to read through it and then I'm going to explain it in more detail and answer questions, because there's nuance to this, so you might have questions. So listen up. There's going to be a total of 10 lecture and lab activities that will take place during certain lectures and labs. They will happen when I feel like it. All right? Each completed activity is worth 1% of your final grade. Okay? The date and time of each activity is determined ad hoc. That's a fancy Latin way of saying whenever the hell I want. And you bet I'm going to pick it on the day when like 4 people show up. Okay? Like, uh-oh, right? Sucks for you. So these activities will take place during a lab or a lecture. All 10 might be in lab. All 10 might be in lecture. 7 in lecture, 3 in lab, whatever combination I feel like. Okay? The questions that will be there, I want to be clear, these aren't quizzes. Okay? They're not pop quizzes. That's an entirely different, I'll explain why it's different in a moment. The questions are related to important concepts covered in that respective lab or lecture. The answers, listen carefully, and this is recorded. So when you go to the dean and be like, he never said, first of all, it's written down. Second of all, I have proof I did. It has to be answered legibly, like written by hand, on a clean letter or A4 size paper. That's like a standard size paper. There's technically a slight different size, but that's the standard size paper. Okay? No half papers, none of that. Those are notorious for getting lost. And if you do that and it gets lost, you're screwed. I will not give you paper. I don't have paper for you. And you must have your own paper. I don't really care if you share the paper, right? Like if someone has a bunch of paper and you give it, fine, that's fine. But it's just as long as I'm not giving it to you. All submissions must include the student's name, student number, student effects, email address, and the date. Used to always say like, and which activity number it was, but no one could remember, including myself, so that doesn't matter. All submissions must be made, listen carefully, all submissions must be made by the person completing the activity, okay? If you're like, oh, I'm going to help you out, but I'll hand it in for you. No, do not do that. No. If you have a broken leg, I'll come to you, fine. But you better have a broken leg. And then you'll hand it to me. Everybody submits one. You are not going to submit one on behalf of somebody, even if you're just carrying it for somebody else. And you're not going to give yours to somebody oh, you're walking up here, take it for me. No. You're going to come and give it to me. I'm going to read your name and look at you and be like, yes, that's you. Okay? So I need to know you did it. Any violation of this, I'm going to give you 0%. It's going to be academic misconduct. That's it, academic misconduct. Even if you're just being a bro, and you get 0 on all this, not just that one, on the whole category. The final grade you could get would be capped out at 90 then. Like, you will get 0 on this immediately. I've been doing lecture activities since like 2015 or something, right? And I only ever had to do this once. It was back at Western. So just it's easy to not break this rule, okay? Cool. Whatever, yeah. And they must be submitted on time. Again, do I like late things? If I say it's due at, let's say, 12:20, and I'm packing up and I'm leaving, you're like, oh, here it is. I'll be like, bye. I'm not taking it with me. If it's on time, it's on time. If it's late, it's late. I don't care how much of an asshole you think I am by leaving without your paper. If it wasn't on time, it ain't on time. Okay? If any of these rules are violated, you're going to get a 0. The only exception is that time that you hand somebody else's in or somebody else hands yours in or whatever. And then the exception is that you get 0 on all of them, not just the one. The good news is they are entirely open book. I actually strongly encourage you to all work together. Talk. A lot of times the question will be like, what's his email address? And you'll be like, oh, it's like literally right there. There'll be more nuance and detail than that. Like if I give you 5 minutes, expect it to take around, a proportionate amount of time. But often the questions are going to be like nearly copy paste from something from the course website. You can use the course website, okay? But at the end of the day, all the work must be done by the individual person, okay? By hand, submitted to me. The point of these things are, one, like I was saying last semester, I never, for more than a decade, my attitude has always been, I don't care if you don't show up. If you're doing well, if you don't show up and you're doing well, what do I care, right? The problem lately is, though, there's like a crossover point where now more people aren't showing up and they aren't doing well, right? Fail rate last semester was the highest I ever had it, okay? First year computer science tends to have a very high fail rate. Last semester was crazy. So I'm not going to tell you how much it was. So yeah, this gets people to show up a little bit. Also, to be clear, there's no makeup activities. You miss an activity, you miss an activity. You get 0. If you get an accommodation, if you get an approved accommodation, I'll shift the weight of the missed one to the final exam with the accommodation. I can tell you right now, they're going to be like, you missed what? They're probably going to be kind of unhappy with you if you're going for 10 accommodations of this, something like this. Again, no makeups, just shifted weight if you get an accommodation. Okay, yeah, the point of this is it gets you here. 2, it gets you to work together, which is good. 3, it gets you, it gives me a chance to, if I pick something like, okay, look, I want you to create an instance of a node and then have it chained with 4 other nodes with these values in it. If that's the activity, that tells you oh shit, this is important, okay? So it's a way for me to let you know, really hit it. It gets you to engage with the content we just learned. It gets you to to do something that is important, right? So there's a lot of value to this. And everyone likes to say by the time the exam comes, writing code by hand, well, you're going to be doing it in these anyway, so you're going to have plenty of experience doing it, okay? Any questions about the lecture activities? Again, they are whenever I want them to be, okay? Email contact, like last semester, of course you can email me. But remember, there are some questions that are appropriate for email, some that aren't. Things that I can answer, questions that I can answer trivially, yeah, that's a great email question. But one that's going to start to take a little bit of time to go into the nuance, usually programming questions tend to be I can't answer this in an email. This is very difficult to answer in email. You got to come to office hours for this type of stuff. Happy to answer those questions, but you got to come to office hours. Email is great for certain types of questions. Maybe in other classes it works really great, but with something like intro programming, it's not easy to kind of get into the weeds with a lot of that stuff via email. Not to say don't email me, no, by all means. But don't be surprised if you're on I'm working on this chunk of the assignment. In this function, I'm really stuck. If my response likely is going to be like, great question, come to office hours. And then I want to talk to you at office hours. Office hours, come to office hours. Yeah, and yeah, we're not here to give you answers to anything. We're here to get you to understand how to get to the answers of things. Anything I ask you, like when I give you an assignment and I say do A, B, C, D, E, F, G, there is no value to me that you wrote the right answer. Like at the level of getting, like having the right answer down means nothing to me. You having done it and understanding and getting the right answer is what has value. I'm never going to give you an answer to anything. I'm going to give you answers to I'll give you answers to questions that aren't like the answers to the questions I'm asking you. I know the answers to the questions I'm asking you. I'm not asking you to tell me that. I need you to do these things to learn these things. That's the point. Attendance is mandatory. Copyright policy, I own everything unless stated otherwise. Class recording policy, you can't record me. You can't take pictures of me. You can't do anything, but don't worry, I do it for you. Right? It's on YouTube. Academic integrity, don't cheat. I'll go after you. I think it's funny. Use of plagiarism, I'm going to check if you're cheating. You can get a tutor, but remember, be careful with tutors. Accommodations, you can get accommodations, Tramble, pretty boilerplate stuff. Careful with scents, don't put up perfume or cologne or anything. It makes me sick. Yeah, boilerplate stuff. Any questions about any of that blitz right there? It's all there. I just went through it quickly for your benefit. What I just did should not be deemed sufficient. It should be like, if you want more details, have a read, okay? Questions, 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 questions? Make sure I'm zoomed in the right amount. Okay. Let's go back to the main page. Was there anything else here? Getting set up. Who here got set up? Oof, come on. All right, getting set up. So I'll quickly go over this. So last semester, we used Colab, right? We were programming in Python. And in order to do that, we used Google Colab, which was great. We could have, so every line of code you wrote was actually run on a computer somewhere else, right? You were connected to it, it was in the cloud, right? But we could have done it in a way where you were writing code on your computers. That would have been entirely fine. And to do that, though, you would have to have the software on your computer that knows how to take the Python code you wrote and actually run it on your computer. Because your computer doesn't, a Mac would know by default. I don't think Windows does by default. You need to download Python stuff. Well, this semester we're using Java, and we need something similar. We need a tool that can take the code and turn it into something that your computer can actually run. And to do that, we need a couple of tools related to Java. A lot of you, raise your hand if you play Minecraft. Yeah, okay, so actually not anymore because it's not in Java anymore. But in the olden days, let me take a step back. Chances are you have something on your computer called a Java runtime environment. It's called the JRE. It is the thing you need on your computer to run Java code. But we need something called the JDK, the Java Development Kit. It has the Java runtime environment, but it has something else. So the JRE is the thing that makes it so your computer can run Java programs. The JDK includes that, but it also has the thing that can turn your Java code into the thing that's like a Java program. And then the Java program can run on your computer. So it includes a little more. So if you're I already have a JRE, not good enough. We're going to use OpenJDK. This is a really big JDK. Yeah, now listen to me carefully. The correct way to do this is to go and download the JDK onto your computer, okay? But having a JDK just takes Java code and turns it into something that your computer can run, all right? We also want an IDE, an integrated development environment. That is like the thing that you like if you're like in Microsoft Word, oh, what is Microsoft? Well, that's a program you use to write stuff in, right? That's like what the IDE is, but it has a lot of bells and whistles for writing code. So it's the environment where we write our code, and then we can say like run, and then the JDK takes over and actually runs it. You used Colab. Colab was your IDE, a web page, that page where you typed your code in and you hit run, right? But when you hit run, you were using like Python's version of the JDK, all those tools to actually run the program. So the IDE was like how you interface with your code, but that JDK, or Python equivalent, is how your code actually ran on the computer. Okay? What we're going to use is something called IntelliJ. And you can download it by clicking this button here, and it'll take you to the website to download IntelliJ. It is a wonderful programming environment. In fact, come on. I'm going to open it right now. IntelliJ. I hope, yeah. All right, this is what it looks like. Watch, I'm going to have like assignment 1 solution in here or something. Screwing around. Okay, I'm lucky. So here it is, right? This is what it would look like. This is where I write my code. But I mean, it looks like there might be something wrong. I don't know why. But let's see what happens if it's indexing. This will be the environment we use. It's called IntelliJ. It's a very popular. This is like industry standard type stuff, right? I'm not giving you like, we're learning to code IDE. I'm giving you like, this is like what the big boys use, okay? If you are taking more computer science classes, I would recommend, so you can like go and download IntelliJ from JetBrains is like the company that makes it. And you're a student, so they give you all like the awesome stuff for free. They want to get you hooked, right? And then, you know, so you use these tools. You're used to these tools. If you're a computer science student, I recommend you go download something called the JetBrains Toolbox. That's that little like thing here. And it's something that lets you like manage several different IDEs. If you're a computer science student, chances are you're going to want one for Python. You might want one for C. You might want, and so on and so on and so on. So if you go out of your way and download the Toolbox, it gives you like when you open it for the first time, you'd see something like this and be like, oh, I want that one. You click install, and it just manages it all for you. All right. Now, I don't know if this is going to work. It might not be happy because I'm seeing some underlines, and I'm not sure why right now. Oh, because I gave it a Boolean. Oh, because I was showing it won't work. Oh, yeah, by the way, here's a funny little dip. Can you see this reasonably well at the back, by the way? Would it be better if it was bigger, or is it fine? I'm looking at the back for responses from y'all. You think it's fine? Or no one else said anything, so you speak for everybody. Yeah? Pardon? Like this, like, can you see that font? Is it readable to you, or is it too, remember, it's over there too. Like, can you okay, cool. Just as a thing, remember how in Python, like, oh, the types, you know, it figures it out. See, I'm going to talk more about this in far more detail, but just as an interesting little thing, this is a function. It takes mass, which is a float, and volume, which is a float. They're said to be floats. You know, like we did type hints in Python, but they didn't really matter. You could put a different type in there. Well, in Java, it matters. In fact, it's saying, no. And if I try to hit run, it's going to be like, no, I'm not even going to run, which is awesome. We like this. You might say, one sec. You might say, oh, it's more restricted. No. You don't want broken code to run. You don't, if your code's broken, you want it to not run. It's helping you. Yeah. Okay, I'll figure that out for, let me have a quick look here. See if I can, let's see if we can find it together. Settings. It's probably in here, right? Editor. General. Font. Let's go let's go crazy. 16. Is that nicer? Yeah, very visible. Cool. So let's give this like 2 values here. 1, 2, run. ugh. Okay, great. It gave me an answer. It ran. Cool. So this is the IDE. When I hit run, and we see all those like blah, 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 that was the JDK taking over, turning that code into something that can run and then running it. Okay? The IDE is just like the editor with a lot of bells and whistles that helps you manage your code. We're like, this whole course, we're only ever going to interact with like the tip of the iceberg about what something IntelliJ can do. But it's still good for you to be familiar with these environments. And don't worry, it's designed in such a way where you don't need to go navigate crazy cryptic Byzantine menus very much. Now, I said, and I haven't tested this in a while, so maybe I'm wrong. The correct way is to go download the JDK and then download the IntelliJ. And the IntelliJ will be like, oh, I know where it is, right? And you can run it. But if you don't download the JDK and you open up IntelliJ is going to be like, you're missing a JDK. Do you want me to download one for you? And you can, yes. So it kind of does that step for you, just FYI. I do say, though, here, let's go back. Use JDK version 11 or higher. I think the course is actually designed to use version 17 right now. I can't imagine. When a new version of a programming language comes out, they add a couple more bells and whistles, but it's usually fairly like esoteric stuff that like we wouldn't be using. So I don't think it's going to matter. But usually, like if you're in IntelliJ or you go to download the JDK, it's going to recommend the most recent version anyways. Cool? Questions, thoughts, concerns, comments, anything? Happy, sad? Yeah?
Colab had like stuff you would have to import if you're using an IDE last year. Is that the same with like IntelliJ? I know one of the assignments I had to do on Colab that I did on VS Code.
Oh, okay.
Is there any reason I could not still use VS Code, or do you want us to?
Okay, you can use VS Code. No. My answer is use IntelliJ. If you're like, no, I'm going to use VS Code, fine. But if the marker, if you can't get something working, you're like, I'm using VS Code, I'm going to be like, I don't know, I'm not going to help you. I don't know, I can't be tech support for that. And if you're able to submit your code to the TA and they can mark everything perfectly, great. But if there's like an issue because of how something was set up, we're going to have a problem. I don't think anyone's had any issues in the past who like really wanted to use VS Code. But the safest thing you could do is use IntelliJ, because then you know you're on the same page. Yeah. VS Code is another like editor. It's another IDE. You can write Java in Notepad. Like you can go here and be like, all right, like you can write, what is this? Oh yeah, get rid of that. No, yeah, they're not there, I know. Like you can start writing Java code here and then tell your computer to turn this file into a runnable Java. That's entirely fine. Like it's just text. But the JDK is the thing that looks at the text and converts it into a Java program, assuming the syntax and everything's correct. But you'd be psycho if you did that, right? Don't do that. It's not 1975, right? Yeah.
For our high school class, they made us use Notepad++.
Notepad++ is cool because it does have plugins to actually do a lot. But use a real IDE, you know? Notepad, why, did you see Notepad++ pop up on my thing? Notepad. It's there. Oh, why did it not show up this time? Oh. There you go. Yeah, see, it's fantastic. Notepad++ is my go-to text editor, don't get me wrong. Anyways, other questions? So yeah, if it wasn't obvious at this stage, we're using Java. Why Java? It's one of the most popular programming languages there are. How is it? Okay, popular languages. I think this is it. Let's go have a quick look. No. Right now, Python's at the top. These guys are always like, well, Python, wow. Python, what? In 1 year, wow, Python, woo. That's cool. These ones, they're always your Python, C++, Java, C, C#, even JavaScript. First of all, these are all very similar languages, to be clear. Python's the most different one. But these are all very similar languages, and they're always kind of like moving around, all right? Java right now, I guess, is number 3. But you can see it's a very popular one. C++, we're not using it. You're welcome. There's nothing wrong with C++ in general, but I have a long list of reasons why let's stop. Why are we not using Python? I could teach you this class in Python. I very well could teach you this class in Python, and it would be great, I'm certain. But one, I think it's important to early on get exposed to different languages. That's always something very valuable there. And that's good because you learn another language, you start to learn some of the nuance of those specific languages. But you also get a chance to see how they're basically the same. So it really does help quite a bit. Second, Java gives you, so first of all, Python's a scripting language, which is like, oh, lightweight, awesome language, quick and dirty, yeah. Anything you do with Python, you can do with Java. Anything you do with Java, you can do with Python, don't get me wrong. But Java's more like, it's a big language, right? And it's designed for like big systems and whatnot, okay? And this is very high level. I'm skipping a lot of nuance here. And with Java like forces you to program more correctly. Python's like loosey-goosey, but that loosey-goosey lets you trip yourself quite a bit, right? Where Java forces you to program a certain way that makes it so you're going to eliminate so many potential issues that you could have if you were using Python that you won't or can't if you're using Java, which makes it ultimately easier for you, which is a good thing. And there's a couple of other tools built into the language of Java that I think makes a course, specifically like this type of course, where we're learning about data structures. Java gives us a lot of cool tools that I think overall make it easier for you. So one, it's a different language. Two, I know everyone's like, Python, it's so easy. Yeah, it's easy for like programming 101, but I think it actually gets in your way for 102. I think Java would make it easier for you. Similar arguments could be made for C++ versus Java, but there's a couple of reasons why I don't like C++ for this level. There's nothing wrong with it. This course used to be in C++. I used to teach this course in C++. But Java has more things that I think makes this course easier than C++. C++ has some too, don't get me wrong, but Java has more that I think makes the course easier. But C++ makes you like have to think about a lot of other details that, although are important for understanding how computers work, if the point of this course was to learn like how do the computers work, there'd be a better argument to use C++, but that's not the point of it. That would be a very like implicit learning objective. It's not an explicit learning objective. Java is not an explicit learning objective of this course. This course is about data structures, but we're using Java. The language really doesn't matter, but I want to pick something that complements it really well. C++ would require you to spend quite a bit of time dealing with things, which is a good learning exercise, don't get me wrong, but you'd spend a lot of time dealing with like, oh, I didn't deallocate my memory. Where did I mess that? Where's my memory leak? Like you'd be focused on solving those problems, which really aren't about what's a stack, which is one of the data structures we're going to learn about. So that could be said. C, we could do it in C. It wouldn't be, there'd be a lot of reasons not to do it in C because C is not really object-oriented, and we're going to make use of a lot of objects in this course. C# and Java, flip a coin, whatever. At this stage, you're not going to notice much of a difference. JavaScript, there's a lot of good, cool things about it, but it has a lot of the shortcomings of Python that we're also going, and other shortcomings. So really, if you were to look at this list, Java is the correct, in my opinion, it's the correct choice for this course at this level for us, FYI. What else? You can use other JDKs. I think technically I use the Amazon one. You can use other IDEs. Well, here, if you really prefer another IDE, reach out, ask. Chances are you're going to be fine, but run it by me first. But officially, what's official? This is what's official. I've still got issues. Yeah, anyways, cool. Other questions? Any? Oh yeah, here we go. If you're confused, if you're really stuck, I'm sure you can figure it out. And there you go. Because if you come to me and you're like, I'm stuck, it's not working, you want to know what I'm going to do? I'm going to go here. Because I'm not going to know what the issue is. So you can just skip me. Okay, last chance for questions before we get into actual content. And by actual content, I mean I'm going to repeat myself for a bit. All right, intro. Read the outline first and foremost. Like I said, my quick little blitz through the outline is by no way sufficient. If you said, you never said this, but it's in the outline, that's on you. The main focus of this course is the organization and manipulation of data and how we're going to organize data in different types of collections and the pros and cons of those things. Things like stacks, queues, bags, and trees are going to be the focus. Stacks, queues, and bags are linear data structures. Tree is a nonlinear data structure. There are a lot more data structures that we're not going to cover. Some of these you'll cover next year in 215, or no, 250, whatever, 255, I think. Bags are like lists, basically. It's just a different name. Data structure, well, what's a data structure? A data structure is some structure used to store and organize some data. It's a good name. Linear data structures, a linear data structure is one where the data is stored in a line. This is not a very formal definition, but it does give you the idea. There's a beginning, there's an end. If I say you're at index 7 of a list and I say, what comes after? You can answer that, right? That's like the idea of a linear data structure. Generally, everything has something that comes before it and something that comes after it. The only exception would be like the first and last thing. A stack is a data structure, something like a stack of plates, for example, or a stack of pancakes. The last thing put on top of the stack will be the first thing on the stack. So if I got this little pancake and I put them on the stack, it's now the top of the stack. Wild, right? Who here has ever interacted with a stack of things before? Put up your hand. Of course you have. You're already an expert. How about a queue? You ever stand in line before? No? Well, you will one day. So if you've ever waited in line, you're familiar with a queue. The first one so unlike the stack though, right? Like if I add something into the stack, it goes to the top, right? A queue, if I add something to the queue, it goes to like the end, right? What? It's better in a way.
No, I said it's better.
Oh, it better. I know.
Yeah.
Otherwise, way to become the least popular person in the world, right? Or a queue, right? Or we can have like a bag, which this doesn't look like a bag, but you know, it's like a list in Python. And we can have different types of bags. You could have ordered bags where the data in your bag must be ordered some way. It could be an indexed bag, which would be effectively like the list that we're used to in Python. Or we could have unordered bags too. Maybe it's like a set, I don't know. And we also have nonlinear data structures. Sometimes their data has no natural ordering, right? You know, sometimes their data does have a natural ordering in terms of the ordering of the data itself, like what comes after 7, 8. Why? Because numbers work like that. But if I asked you what comes after blue, you're like, I don't know. What comes after my shoe? What does that mean, right? Like sometimes an ordering doesn't really make sense. And sometimes we have like hierarchies of data where there's no real ordering. Or maybe there's kind of an ordering, but it's complicated, right? Like if you think of a file system on your computer, or you can go look at like an index in a textbook or something where you have like chapters and sections and subsections, right? If I were to say to you, like using the computer example, I say like, well, what comes after the root directory? You're like, well, documents and settings? Why? I don't know. Like, how did I order? Like what comes after, like what's after this? Is it this one? Or is it this one? Or is it this one? I don't know. This is a nonlinear data structure, right? You might say, well, this one. Yeah, but why is that one on the left? Why did I put that there? It's alphabetical. Ah, you imposed an ordering, not me, not the data structure. The data structure is just there. And then we can have things like graphs. We're not going to talk about graphs, but a graph is a generalization of a tree. And here's a graph. You know, a graph could represent whatever the heck we want it to represent. And here's an example of like a graph showing like flight routes between different airports, right? You know, there's no such thing as a direct flight from Moncton to New York City, I guess. I don't know how true that is, but you know, if I was in Moncton and you said, well, how do I get to New York? Well, I have a couple of options. Apparently here, there's no flights from Toronto to New York, which is probably not true. But, you know, here's a graph representing how we have got airports and how you can fly between these airports. That's the graph. In a graph, we call these things, anyone know what we call these things in a graph? I know, look, I know at this stage you're like, a graph, isn't like a bar graph a graph? That's a plot. This is a graph. What do we call these things? Node, yeah, or the more correct answer, a vertex. Vertex. And did anyone know what we call the things between the vertices?
A line.
Close. It's called an edge. Doesn't matter for this class. Although you will be using graphs, you just won't know you are. I'll tell you later. I'll blow your mind. All right, and then abstract data types. This is going to be a big part of the course. Abstract data types. Okay, so I talked about things like stacks, queues, bags, trees, graphs. These are like what we call collections. And we sometimes call these things abstract data types, ADTs, because they are an abstract idea of how we want to interact with our data, okay? What they do and how we interact with them. That's like the definition of what we've got on. But we don't talk about specific implementation. We don't talk about like implementations and implementation issues. We will, but I want to separate these things. We want to separate like, well, what's the abstract data type versus an implementation of an abstract data type, right? What I mean is, raise your hand if you used a list in Python, okay? So you interfaced, listen carefully, because this is a huge idea, and we'll end with this idea. You interfaced with the idea of a list, okay? The definition of the list was defined somewhere. However, if you were to open up the hood of that list and look at the code underneath, there would be an implementation. Obviously, when you are interfacing with that list by calling like append or indexing or printing, whatever you're doing with your list, you are ultimately obviously interacting with the underlying thing. But we try our hardest to define an interface, an abstract definition of the list. And this is how I interact with it. And how it's implemented on the other side of this barrier, I don't care. If I can put you in a car, who here has ever driven a car with an internal combustion engine? How about an electric car, right? I know it's kind of weird, right? But in general, you interface with the car the same way. Your pedals, your steering, right? Put it in gear, right? It's the same. So the car is the abstract, like your interface with a car, but the actual underlying, how does it build, doesn't matter to how I interface with it. And that is a very important design concept that we're going to try to enforce a lot. So you've interfaced with a list, but actually how it was implemented underneath didn't matter. It matters in the sense that when I interface with it, if I put my foot on the gas and there's an internal combustion engine underneath, the internal combustion engine is going to be doing its thing. Obviously it's there. But we want to abstract ourselves away from that we don't even need to think about it. And we're going to be doing this a lot. Because we're going to implement a queue, we're going to implement a stack, we're going to implement bags, and we're going to change the underlying implementation. We're going to change that internal combustion engine out for an electric one. And the magic is, your code, you can change it out. Your code up here, when you're interfacing with that stack or a list, not going to change. It's pretty cool. Anyways, we'll pick up here tomorrow, whenever next class is. Any final questions? All righty.